In this video, I'm going to talk about the Fourier series for general periodic functions. In the previous video, I talked about how to obtain the Fourier series for a periodic function with fundamental period of 2 pi. So this lecture will talk about how we can find the Fourier series for a periodic function with any period. Okay, so when we talk about the general periodic function, we talk about any function with a period, for example, 2L here. So here, what I will emphasize here, we will use 2L because it's a little bit easy to in the notation wise, a little bit easy to denote the Fourier series. But if you have a function ft, which is, let's say, period is 5, for example, you can say, yeah, the period is 2.5 divided by 2. This is always feasible. And here, then your L will be just 5 over 2. Okay, so any function, any period function, you can represent as a period, fundamental period. Fundamental period is 2L. Okay. So before talking about how to obtain the Fourier series for general periodic functions, let's do a review of the periodic function for Fourier series for a period function with period 2 pi. Okay. So here, when I mention period, I mean fundamental period. Okay. So the Fourier series for a function ft, which is periodic, of course, with fundamental period 2 pi. So its Fourier series given by ft, which is given by a0 plus summation of n from 1 to infinity an cosine nt plus bn sine nt. So if you don't know why that's the case, you can watch my previous video. So here we have a couple parameters we have to figure out in the Fourier series. This includes a0, an, and bn. So here n is starting from 1 to infinity, and similarly for the bn. Okay, so a0 is different, and a and bn, they follow the same formula. The difference is the n will change as an, or this will change as you have different n. Okay, so in particular, my a0 is 1 over 2 pi integration from negative pi to pi of ft over dt. And an is 1 over pi. So remember, don't have 2 pi. It's not 1 over 2 pi. It's 1 over pi. Okay, so this is not 1 over 2 pi. It's just 1 over pi. Integration from negative pi to pi of ft times cosine nt over dt. And bn is 1 over pi again. Integration of negative pi from negative pi to pi of ft times sine. The difference between the sine and cosine. As I mentioned in the previous video, this is the same as what's happening. So your an is appear in the term cosine nt. So here you also have cosine nt, and bn computed is based on in the original Fourier series representation is a parameter from the sine nt. So here we also have sine. They are consistent. Integration of negative pi over pi ft sine nt over dt. Okay, and this holds true for any n starting from 1 to 2 until infinity. Okay, so that's the Fourier series for a periodic function with period 2 pi. Okay, now the question is, how do I write a general periodic function into its Fourier series? Okay, so the key idea is I want to use what I've already talked about here. I know how to do this one for a periodic function of 2 pi with a fundamental period 2 pi. Now the key idea is, how can I write it back, do a change of variable, and change a general periodic function into a period 2 pi, and somehow use the property I mentioned over here. Okay, that's the key idea. So in terms of that one, let me go to the detail about how we do that for a general periodic function. The first step to write a general periodic function into Fourier series is to change a variable. Okay, so this is how we do the change of variable. So originally, assume I have a ft, which is a periodic function with a fundamental period of 2L. So it's given by left one. Okay, what I want to do is I want to start to change a variable. Let's see, if I change this one to a function of v, okay, such that my fv, I want fv to have a period of 2 pi, because I know how to do this for 2 pi, for the fundamental period of 2 pi. So one way to do this is, well, we could do a change of variable, change the v, my v is just 2 pi over 2L times t. This is fundamental to say. The reason I do this because 2 pi to 2L This one I want if I would augment my 2L by this, so I end up having 2 pi as my fundamental period. That's the reason I do this. Now V, if you do a change over V is 2 pi over 2L times T, which means I have 2 pi, V is pi divided by L by T, because this two in the numerator and denominator cancel out, so which means V is pi over L divided by T. If I do this change of variable, what I do is it's still a periodic function, of course, and the period become 2 pi. Okay, the reason the period become 2 pi because if you change, let's say for example this for the previous periodic function, one is that negative L, positive L, straight L, its value is 0. If you do this way, you can check f negative pi will be 0, because f negative L, when you change it as a variable, the V will be, for this case the V will be, okay, do this one, f negative L is 1, so which means that if T is negative L, right, because V is pi over L times T. When T is negative L, I replace T by negative L as pi over L times negative L, which is negative pi, which means negative pi is 0. That's exactly what's going to happen. Here, of course, your positive pi also be 0. Positive L will map to positive pi, and positive 3L map to positive 3 pi, and negative L map to negative 3 pi. So this is negative L. That's why the period is just, if this is the period from negative L to L, then it maps from negative pi to pi. That's why for this new function fv, it has a fundamental period of 2 pi. Okay, so here it has to be 2 pi. So the fv has a fundamental period of 2 pi. The next step is, well, I can write this fv into Fourier series by using the method I mentioned in the previous video, which is listed here in the star. Okay, so let's do that one. Okay, I know for the fv, because it has a fundamental period of 2 pi, so its Fourier series given by a0 plus summation n from 1 to infinity an cosine nv plus bn sine nv. That's what's happening. So what's the only change is I change the variable from t to v. No, everything else will be the same. Okay, so doesn't change. And okay, also I want to emphasize right here, okay, the a0, just look at the black one, don't look at the red one, the blue one. The red one explains how we change it. Okay, so a0 is given by 1 over 2 pi integrate from negative pi to pi fv dv. So nothing changed, only change from v to variable from t to v. Similarly, bn is 1 over pi integrate from negative pi fv cosine nv dv, and bn is 1 over pi integrate from negative pi fv sine nv dv. That's exactly the same thing. Okay, now we have to, because we don't want to have fv, I want to have ft, right? We have to do some change it back, right, to fv. Okay, ft. Okay, so this is how we do the change. Okay, so because v is pi over lt, okay, so I want to have ft, no, I don't want to have fv, right? So if I change to ft, now I have to change all the v to its t, right? Which happens if I have to have ft over here, this one doesn't change, a0. This one plus summation n from 1 to infinity an, still an, cosine n pi l t. The reason I do that is because I change this v to pi over l times t. So if we time n, that's why it's n pi t divided by l. Okay, similarly we change this v also by this way. So what I do have is bn sine n pi t over l. So that's what's happening for the general form. Okay, similarly for a0 and an and bn, we also do some change, because I don't want to use fv, because I need to use ft, right? So this is what's going to happen. So the a0 is 1 over 2 pi negative pi over pi. If you look at this one, the pi, so here's a pi is a fundamental period, or I just say use a period of my fv. Now if we change it to ft integration, now you cannot use negative pi over pi, because that's not a period for ft. So what really this pi corresponding to the period of fv. So if you change it to ft, you have to change the fundamental period to l, because that's the period for ft, right? So that's why I have to change this to negative l to l and 1 over 2l. Okay, that's what's going to change for a0, because I want to change the period from fv to ft. Okay, because I change v to t, so I have to change the period of v to change the period of t, which is l. So replace all pi by L. Okay, that's what I'm going to have for A0. So for AN, okay, that's quite similar. So AN, I also want to change a variable from FV to FT, right? But if you change V, you have to change all V, right? Because I have two places, not just this V. I change it to T, okay? I also change this V to cosine n pi T over L. Okay, this one I change n pi L to, that's because V is pi T over L. Okay, I change it over here, right? If I change this at 1, I change it here again. Also, I change the integration sign because the period is from negative L to L. And also, this is the period 1 divided by L. Okay? Similarly, we do the change for Bn. Okay, we change Fv to Ft. We change the second V into n pi T over L. And integrate from negative to L, from negative L to positive L. And also divide by L instead of a pi. Okay, so that's what's going to happen. So this is a summary of how do we find the Fourier series for a periodic function with a general fundamental period, okay, of 2L. So Ft, in this case Ft, if this is a, so Ft is a periodic function with period fundamental period of 2L. So Ft is equal to An plus summation n from 1 to infinity An cosine n pi TL T divided by L plus Bn sine n pi T divided by L. Okay, so the only change you can see is from the previous standard one is originally I have cosine n T. Now this one changed to cosine n pi over LT. As you can imagine, if I have a fundamental to 2 pi, your L become pi. Right? So that's why it's just cosine n T. So that's a special case basically. And my A0 is 1 over 2L integration from negative L to positive L Ft over dt. And my An is 1 over L integration from negative L to positive L Ft cosine n pi T over L dt. I should emphasize here this n is from 1, 2, and to infinity. And my Bn is 1 over L integration from negative L to positive L Ft sine n pi T dt. Also n is from 1, 2 to infinity. So that's my Fourier series for the general periodic function with a fundamental period of 2L. Okay, now let me give you an example showing how we can compute the Fourier series for a general periodic function. So here example I give you is Ft is given by At divided by L for the range from negative L to positive L, which means it has a fundamental period of 2L. And also this Ft, this means for all t, which means this means it's periodic with 2L as the fundamental period. Okay. So my goal is want to obtain the Fourier series for this function Ft. Okay, this is the left hand side. I show a picture of this function, which is a C like a saw like a signal. Okay. So when this happens, I want to find this one Ft. So as I mentioned over here, so the form of this Fourier series of this function is given by right here. Ft is A0 plus summation from n from 1 to infinity An cosine n pi T over L plus Bn sine n pi T over L. So that's the form I give over here. So the form is very standard. We just figure out all the parameters A0, An, and Bn. Okay. So A0, according to the definition, A0 is given by 1 over 2 pi integration from negative L to positive L Ft over dt. Okay, so we just replace this Ft by its definition. Okay, its definition here is At over L. Sorry. So it's 1 over 2 pi negative L to positive L At over L dt. Okay, because integration over to A and L, they're all constant. Okay, so we do that. The integration of 1 over 2 pi, we can just keep that, and time A over 2L, and integration, this guy integration will be just, because we have T over here, right? It's A over 2L times T squared. Okay, and evaluate at the negative L and positive L. If you do that one, it's 1 over 2 pi. This is A over 2L times L squared minus A over 2L times negative L squared, because they are the same, right? Negative L squared, negative L are the same, so the A0 will be just 0. Okay, this one I want to emphasize over here. Next lecture I'll talk about even odd function. So this one, the integration is 0 because this ft is an odd function. Okay, don't worry about it. What is odd function right now? Okay, I'll talk about it in the next video. The an is just the 1 over L integration by negative L part of ft times cosine n pi t L and dt. Okay, that's from the definition. Okay, this one we have to do some trick. We have to do some calculation over here. So the method used is called integration by part. So which means I want to first want to do that. I do is keep the 1 over L over here. The integration from negative L to positive L. So what I want to do is I want to move the cosine stuff to the right hand side, right? So which means it is equal to the d of sine n pi TL. The reason this is true because I have to do d sine n pi t over L, which is derivative of that one is it's use a chain rule is a cosine n pi t over L time n pi over L time dt. That's what I have to do the chain rule. That's why I have this term L over n pi to cancel this term. Okay, so that's why it's that case. So we do that when you use this one is equal to the integration of this guy times this guy. Okay, whole thing minus I swap the order of this one is negative L to L sine n pi L t d. This side just this L and L cancel out the AT over n pi. Okay, now this guy is if you evaluate this part of negative L and negative L, you do this. This is what y is 0. If I replace this one L by negative L, it's AL times L over n pi sine n L pi n pi L divided by L. That's what when you replace t by L. Minus you do A times negative L over L times L over n pi times sine n pi over negative L, right? Replaced by n L over replace t by negative L over here. The reason this is 0 because this sine negative is negative sine, right? So I can cancel out this negative sign over here. So that this two will be the same. That's why this is 0. And here I do is negative. I keep this one as the same. So here I do is I do this one as dt. I can move this one outside. So A over n pi over here. Integration negative L L sine n pi L n pi t over L times dt. Okay. So if I do integration, so this one I merge them together, so it's negative A over n, negative A divided by L n pi time. So integration of the sine is negative L n pi cosine n pi L t. So because this chain will do the cancel, this will cancel out, so this will be the same this one, and divided by L and negative L. Okay. So this I merge them together, get this. And this one, so for this part is a cosine n pi L times L minus cosine n pi L times negative L, right? Because negative doesn't change anything, right? So that's these two are the same. So this ends up to be 0 as well. Okay. Now also this is 0 because ft times cosine n pi TL. This is also odd function. Okay. I'll talk about the probability for the odd function in the next video. Finally, the computer Bn. Bn is the 1 over L integration of negative L ft sine n pi t over L dt. So this procedure will be the same as this one I mentioned over here. What happens is I move this one to the right hand side. Okay, then you do exactly the same step I mentioned over here, so you can figure out the solution. I don't want to go to detail here, but if you do all the calculation, the Bn is not equal to 0 apparently, because if there's 0, everything is 0, right? So Bn is equal to negative 2a over n pi times cosine n pi. Okay, so if you replace that ft, you replace here. If I go back to the original form, so my an, this is 0, my a0 is 0, an is also 0. The only non-zero part is the Bn. So the ft is just equal to the summation from n to 1 to infinity of the second part, okay, which is equal to summation n from 1 to infinity, and only this part. Now here I just replace Bn by negative 2a over n pi times cosine n pi. Time, don't forget about sine n pi t over L. That's coming from here. Sine n pi t over L. So this is all Bn. So if I go back over here, if I go back here, so this is my Bn. Okay, so this is my sine n pi TL. So don't forget about this part. Okay. All right. So the next question I want to talk about is, what if ft is discontinuous? So here, if you can see over here, because when I reach at this point, when it's L at this point, L, negative L, or positive L, 3L, whatever, so you have two values basically. When you approach this negative L from the left hand side, because you move from left hand side, it's going to be positive A, right? Which means if you take a limit of ft and t goes to negative from negative side, it goes to L from negative side, which means you're going to move from here, right? You're going to, this is the limit, right? However, if you approach this t to the, you approach the L from right hand side, right? So limit of t, we're going to negative A, because I'm going to start from here. I'm going to keep moving until my negative from the positive side. That's right hand side, the positive side. Keep over here. My value will decrease until it reaches this point, which is negative A. So as a matter of fact, the limit of the ft from left hand at L, from left hand side and right hand, they are not that different. Which means I have limit t go to L minus ft is not equal to limit t go to the L plus ft, which means this is discontinuous. Okay, which means at this point there's a jump over here. So the problem is, if we look at this function over here, this sine and cosine, this sine function, this is always sine n pi t over L. It doesn't matter what n we have, this is always continuous, right? Which means it's hard to say. You only get one value basically. You only have one value over here. So should it equal to this A or negative A or some other values? Okay, so we want to figure out what is the actual value of its Fourier series at this point, because at this point it's not well defined because it's not discontinuous, right? Okay, the answer to this question is the Fourier series at this t and discontinuous point is equal to the half or the average of the limit from left hand side and limit from right hand side, and divide by 2. Okay. In other words, for this case, if I talk about this one for L in this case, okay, L is discontinuous. The limit from left hand side of L is A. The limit from right hand side of L is negative A. So the limit of the value of the Fourier series at this point. So this is the Fourier series of ft. Okay. At this point, it's just given by the average of these two values, which means the average is the limit t goes to L minus ft plus limit ft and t goes to positive L positive, and divide by 2, which is just L plus, let's see, this is A plus negative A, and divide by 2, which is 0. So which is different from n of these two. So you just average the two. Just remember, if ft is discontinuous, its Fourier series, the value of its Fourier series at that point is just the average of the two limits, which means the limits from the left hand side and the limit from right hand side.